Lesson number 13 talks about linear regression analysis, and the items needed for this lesson are your TI-83 calculator and a formula sheet for linear regression and ANOVA, and you can download that from the website, and let me show you what it looks like. So this is the formula sheet. On the top half is the linear regression formulas, and then on the bottom half, I'll scroll up, is the analysis of variance. That's what ANOVA stands for, formulas, and this will be the lesson that we're going to do next week. So let's leave that second half alone. We're just going to concentrate on the top half formulas, and we're going to come back to that in just a minute. So another way to say this is simple linear regression, and the word simple doesn't mean easy like the normal definition. There's actually another definition. I'm going to explain that in a little bit. So linear regression is a statistical procedure where you're given a set of x values and y values, and you'd like to know the following. The reason why you're given x's and y's is because in the word linear regression is the word line, and if you remember, lines is y equals mx plus b, and the variables are the y and the x. The m is the slope and the b is the y-intercept. So we need x's and y's, and that's why we use x's and y's. So we want to know, number one, are the data linearly related? Typically in chapters from the textbook, they always ask this question. And this is a silly question because if the answer is no, we could not go any further since this chapter covers linear regression. It doesn't cover nonlinear regression. So the answer to this question for us this semester is always going to be yes, they are linearly related because we're doing linear regression. If the answer was no, we wouldn't be able to do anything. So we're going to skip over that one, never ask it again. Number two, what is the strength or correlation of the linear relationship between x and y? The strength of the relationship is the letter R. Okay, we're going to explain that in just a little bit, a little further. Number three, what percentage of the value of y is the result of the value for x? And this is called the coefficient of determination. We're going to cover that also when we do a problem. And then finally, four, what is the actual equation of the linear relationship between x and y? And this equation is called the regression line. Sometimes it's called the least squares line. Sometimes it's called the best fitting line. Depends on the textbook that you use. The steps. We're going to go through these in a problem, but let's outline them so you can go back and you can review if you need. Given the x and y values, we want to find new values, which are called x squared, y squared, and x times y. And then we want to find the sums of all of these. We're going to cover that in just a minute. Step two is then find the value for SSXX, SSYY, SSXY. The SS means sum of the squares, and I'm not going to test you on that, but it's just a procedure, and these are just names, so we're going to show you how to do that in just a second. And they kind of match up. If I scroll over here, these SS values are on the formula sheet. And since you have the formula sheet for the test, you don't have to memorize those formulas. Step three, using the values from step number two, find the value for r and r squared. And then finally, step four, find the value for a and b to complete the process of finding the regression line. So the best way to learn linear regression is actually just jump right in and do some examples. So here's example number one. A statistician is trying to find the relationship between exercise, which they're calling x, and the cholesterol level, y, okay, of U.S. adults. So below is a table of a sample of the findings. So we have a person that exercises 10 hours a week, and we found their cholesterol level to be 181. So that's one person, and they come as an ordered pair. The next one, there's a second person, exercises 12 hours per week, and has a cholesterol level of 164, and etc. all the way through the list. And we ask ourselves a few questions here. Okay, question A is find R, which is the correlation between the hours of exercise and the cholesterol level. Okay, well, if you go to your formula sheet, you'll notice that R is calculated by finding the SSXY divided by the square root of SSXX and SSYY. In order to calculate this, though, we need those values. And if we go to the left, here's those values right here. So we're going to have to follow this formula, this formula, this formula to get these three values. And then we can find the value for R. And I'm going to explain it a little bit more in just a second what R actually means. In order to calculate those values, here's what you do for every linear regression question. You have to create three new columns. So we need an x squared column, we need an x times y column, and we need a y squared column. Those are calculated by basically taking the values over here. So the x squared column is going to be taking whatever the x is, and you're going to square it. So in your calculator, one at a time, okay, we're going to find there's the x value 10. So we're going to take 10, we're going to square it, and we're going to get back 100. So we fill in 100 here. And then the next one is 12 squared, which is 144. And we fill in as we go. So 5 squared is 25, 0 squared is 0, 3 squared is 9, 4 squared is 16, 7 squared is 49, and 5 squared is 25. Now to find x times y, we're going to take the corresponding x and multiply it by the y. So we're going to take for the first one, 10 times 181. And that's going to give us 1810, and we're going to put that value right here. And then we keep on going. Okay, so for the next one, we have a 12 times 164. So 12 times 164, we're going to get back 1968. And then we're going to do for all the rest. So 5 times 198 is going to give us back 990. 0 times 245 is 0. 3 times 175 is going to give us back 525. 4 times 162 is 648. 7 times 135 is 945. And finally 5 times 163 is 815. Okay. Y squared is now taking the y value and squaring it. So we're going to take 181. 181. We're going to square that. We're going to get back 32,761. And then we're going to do the rest. So we're going to take 164 squared. Okay, that's 26896. 198 squared is 39204. 245 squared, 60,025. 175 squared is 30625. 162 squared is 26,244. And then this one is 18,225. And then finally we have a 26569. Okay, so we fill in it. This is what you do for every linear regression question. So they're giving you an x, they're giving you a y, and then you create in three new columns, fill them in. Now what we want to do is we want to add up each column separately. So we're going to add up all of the x's. So 10 plus 12 plus 5 plus 3 plus 4 plus 7 plus 5 is going to give us back 46. We're going to add up all these numbers. 181 and 164, 198, 245, 175, 162, 135 and 163, 1423. Okay, add up all the x squareds. We're getting back 368. Add up all the x times y's, making sure I don't make a mistake. Okay. 7701, and finally add up all of the y squareds. 32761 plus 26896 plus 39204, and etc. Okay, 260549. Okay. Now, each one of these, the symbol, let me grab another sheet of paper just to throw a few notes on here. The symbol capital sigma stands for sum, or adding everything up. So we can label each one of these answers. We summed up all of the x's and we got 46. So 46 stands for the summation of the x. 1423 is the summation of the y column. We added them all up. 368 is the summation of x squared. 7701 is the summation of x times y. And finally, 260549 is the summation of y squared. We added them up, so that means the sum. So when we refer to these symbols, we're going to substitute in the values for this particular question. So when they say find R, again, if we refer ourselves, I'm just going to bring again over here. Right, we find R, they're referring to these three values, and these three values are over here on the left. So keep this sheet available to you, and I'm going to just follow along right here. Okay, so in order to find R, I need to find SS sub xy. According to your formula sheet, that's the summation of xy minus the summation of x times summation of y divided by n. All right, we need to fill in for the summation of xy, the summation of x, the summation of y, and n. We got to fill in for those values. Well, we get them right up here. Okay, we said the summation of xy, the sum of the xy column is 7701. There. Okay, the summation of x we found to be 46. We're going to multiply that by the summation of y, which is 1423. And those two values are going to be divided by n. N stands for the number. In that case is the number of people we talked about. And again, they came as an ordered pair. So the first person was 10 hours of exercise, 181. The second person was 12 and 164 for exercise and cholesterol level. So we had a total of 1, 2, 3, 4, 5, 6, 7, 8 people in our sample. Okay, so in our calculators, we're going to put in 7701 minus 46 times 1423 divided by 8. Okay, it looks just like that. And then we're just going to hit enter, and we're going to get back negative 481.25. Negative 481.25. I'm going to put a box around that. We're going to use that in just a second. Okay. Next formula asks us to find SS sub xx. This is the summation of x squared minus the parentheses, the summation of x, the quantity squared, divided by n. Again, that's what's found on the formula sheet, so I'm just copying it down for you. We need to find the summation of x squared, then the summation of x, and also n. And those, again, are right up top here. So the summation of x squared, that's the third column, which has a total of 368. Now, we got to be careful, because that's the x squared column added up. Now we want the summation of the x column, that quantity squared. So the summation of the x column is 46. We're going to square that value and then divide, again, n happens to be 8. Okay, so in our calculators, we're going to put in, let me see if I can get it, there we go. So 368 minus 46 squared divided by 8. 103.5. And the last one we're looking for is SS sub YY. And this is the summation of y squared minus the summation of y, the quantity squared, over n. We're looking for that, we're looking for this, and we're looking for this. So, the summation of y squared, that's the y squared column added up, that's 260,549. We want to subtract the summation of y, that's 1423. We want to square that value according to the formula, and we want to divide by n again, which is 8. Okay, so in our calculator, we're going to put in 26059. Oh, sorry, 260,549 minus 1423 squared divided by 8. Okay, we're getting back 7432.88. So we have everything that we need to find our value for R. So R is SS sub xy divided by the square root of the quantity SS sub xx times yy. And that's on your formula sheet. So now we're going to fill in for each of these three values that we just calculated. SSXY is negative 481.25. We're going to divide that by the square root of xx, which is 103.5 times 7432.88. Okay, so in our calculators, negative 481.25 divided by the square root. Whoop. Oh, hold on a second. Negative 481.25 divided by the square root, there we go, of 103.5 times 7432.88. Okay, there it is. And we're getting back negative point, we're going to go to two decimal places, negative 0.548, let's call it negative 0.55. So that's the value for R. So that answers the first question. Let me scroll up again. The first question says find R, which is the correlation between, in this case, hours of exercise for X and cholesterol level, which is our Y. Now let me give you a few notes over here. R has to take on a value between -1 and +1. So if you get an answer for R after the first question of anything outside of this range, for example, if you get an R value back to be like 1.83 or 2.64 or negative, 1.12, you know you made a mistake. You have to be somewhere between -1 and 1, so it's going to have to be a decimal. That's bigger, and bigger outside the range. So you know you made a mistake, which means you better go back and you better recalculate the summation of X and Y and all of those values because you probably made a mistake someplace. Now, this stands for the strength of the relationship. 0 means there is no linear relationship between X and Y. Okay. This, of course, means there's a positive relationship if you go to the positive side. This means you have a negative relationship if you go to the negative side. And the closer to 1, the stronger the relationship, or the closer to -1, the stronger the relationship. Now, you can only be on the positive or negative side because it depends on the relationship. I always say in my classes, I always make a reference to, let's say, your parents or your brother, your sister, your boyfriend, your girlfriend, or your husband, your wife, whatever. Let's take parents. If I ask somebody, what is the relationship with your father? You would either say there is none, or you would say it's either positive or negative. You can't be on both sides at that given moment. And of course, then the stronger, so there's a sliding scale here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and finally 1. So if you tell me that the relationship is a 0.1, it's positive, but it's not very strong. If it's a 0.5, that means it's a positive, but it's, kind of middle of the road. If it's a 0.9, that means it's very strong. You have a very positive, strong relationship. And the same thing over here on -1. The closer to -1 you go. So if a multiple choice question came up on a test and we wanted to know which value for R represents the strongest relationship, and I gave you back values to be, let's say, 0.67, -0.73, 0.12, -0.34, and finally, let's say, 0.26. Which one represents the strongest relationship? You would then say that that is -0.73 because that's the largest value closest to either -1 or +1. That's the strongest. The next strongest would be then the 0.67, and then the -0.34, the 0.26, and the weakest. So if this had asked which one is the weakest, you would have said the weakest is 0.12 if these were the 5 choices. So what we had, that's a little background info, we have a value of -0.55. So we would say that it's a negative relationship, so we go up here and we're going to say, well, the more you exercise, since it's a negative relationship, the more you exercise than negative, the lower the cholesterol is. If it was a positive relationship, this would go up, but that makes sense. The more you exercise, the lower your cholesterol actually should be. That makes sense. So there's the value for R. Part B then says, find R squared and state its meaning using 2 sentences. All right, we can do that. So R squared, we take the -0.55 and we square it. Okay, so in our calculators, I'll go over here. -0.55 squared, 0.3025. I'm actually going to write down all those decimals. You're going to see one in a second. That's the probability. So I'm going to move that over 2 decimal places and I'm going to state 30.25% of the, whatever the y variable is, in this case that's cholesterol, is directly related to the x variable, and that would be hours of exercise per week. So it's always the percentage that you get for your answer, and then you always say of the, and you put in the y variable, and that is directly related to the x variable. So we're saying 30.25% of your cholesterol is directly related to how many hours you exercise per week. And then you can say the remaining, in this case got added to 100%, so you have 69.75% left, and you're going to say that is due to other variables besides cholesterol, so due to other variables. So the answer is part B, find r squared and state its meaning using two sentences. So there's your two sentences. So what we're saying is, now the reason why this is called simple linear regression, simple, the word simple means, okay, so the word simple means using one x variable to guess one y variable. So we're using 1x to guess 1y. So what we're doing right now is we're simply saying how many hours of exercise, and we're trying to figure out what somebody's cholesterol level is. So that's the ultimate goal, is to try and figure out what's somebody's cholesterol level and guess. Well, we know that there's other variables over here, but see, we can backtrack and say, well, your cholesterol level can be backed up by saying, well, according to what we found a second ago, 30.25% of your cholesterol level is because of your exercise. Then what we can do is we can fill in some other variables here that'll total up the rest of the 69.75%. So the next question I always ask for part C is, state 3 or 4, in this case 4, state 4 other variables other than hours of exercise that can be used to predict cholesterol. This would be a question if a teacher were to teach you multiple linear regression. And the word multiple stands for multiple x's, where simple linear regression stands for just one x. Multiple linear regression stands for multiple x's. So if we wanted to answer this question, so this is part C, give me some other variables besides hours of exercise to predict cholesterol level. Well, you could say, your eating habits. You could say your heredity, your heritage. What did your mother and father pass down to you, and etc. I mean, you can't get this wrong. You can fill in all of this stuff. Do you smoke? Do you drink? Are you female? Are you male? What's your ethnic background? Those all play roles. Do you take other medications? And you fill it in as you go. So, but I like my students to understand, the context of linear regression. We're doing simple linear regression, which is 1x to 1y, but you could down the road do multiple. So I'd like you to think about that stuff. Okay. The next question talks about find the equation of the regression line. Okay, in finding the equation of the regression line, I'm going to go back over to the formula sheet. Here we go. Okay, and this up here, okay, is the equation of the regression line. Y, that's a hat, okay, and that distinguishes this y linear equation from a regular y algebraic equation. The hat means it's from a statistical line, so y hat equals a plus bx. Okay, so we'll get a new sheet of paper. So in finding y hat equals a plus bx, your goal is to find a and b. All right. according to our formula sheet that you're going to be looking at, I just want to reference it again. There's the formula for B and there's the formula for A. And they're actually pretty nice, straightforward formulas. So let's look at B first. So you're going to look at this formula sheet. I'm going to remove it from the screen and I'm just going to copy it down over here. So B is SS sub XY divided by SS sub XX. That's according to the formula sheet. I'm going to bring back the sheet that we just did a second ago, and we already have those values. So SS sub XY is negative 481.25. Okay, so SSXY, negative 481.25. We're going to divide that by SS sub XX, and we found that right there previously to be 103.5. So we already did the work. That's good news. We're going to divide those two in our calculator. Negative 481.25 divided by 103.5. Okay, we're getting back negative 4.65. So that's our value for B. So we're halfway home. We got B. Now we have to find A. The formula for A, according to your formula sheet, is 1 over n summation of y minus b times summation of x. Okay, so we have to fill in for n and all of these. You can notice that because B is in this formula, we have to find B first. It doesn't go alphabetical because we need B to substitute in to get A. So 1 over n is 1 over 8. Because remember, n was 8. There was 8 people who exercised and had cholesterol levels. The summation of y, if we look previously, was 1423. Be careful now, we're subtracting in our formula, and then b happens to also be a negative, times summation of x, which was 46. That double negative ends up being a positive, and sometimes you get a double negative, sometimes you don't. In this case we did, so we end up 1423 plus 4.65 times 46. Okay, so in our calculators, 1 divided by 8, parenthesis, 1423 plus 4.65 times 46. Okay, we're getting back 204.61. Now, we're going to use that to fill in for my A, and so the answer to letter D, which is what is the equation of the regression line, we're going to say y hat is A, 204.61, plus B, but B is a negative, 4.65 times x. Okay. Now I always ask my students, then in this case, what is x, what is y? If you recall, x is hours of exercise, and then y is going to be the cholesterol level. So this gives us now not only do we know the relationship that we found a second ago, which was negative 0.55, which is a medium relationship, we now found the actual equation of the relationship. We can use that equation to predict, and I'm going to scroll back here now for, that was D, find the equation. E, what is the predicted cholesterol level of a U.S. adult who exercises 2 hours per week? And then F says, what is it if we exercise 12 hours per week? Well, the thing you need to know is if you're going to make predictions on X values, so an X value of 2 and an X value of 12, you have to make sure that you're within the low to high of the actual X's that are given. And so you know here the low for X's now is 0, and the high happens to be 12. So that means you can predict anything 0 to 12, but you cannot predict, so I can predict 0 to 12, but I cannot predict anything lower than 0 or anything higher than 12. So if I'm asking for a question like that, then you wouldn't be able to satisfy that, and that's what happens in letter G. What is the predicted cholesterol level of a U.S. adult who exercises 20 hours per week? 2's okay, 12's okay, that's within my range, but 20 is not okay. So we're going to get to that in just a second. So the first one asks for 2. So you put in 2 for your X. you can say y hat is 204.61 minus 4.65 times 2 hours per week. So if somebody comes and asks you, well, geez, what should my cholesterol level be if I exercise 2 hours per week? We're going to say 204.61 minus 4.65 times 2. 195.31 is the predicted cholesterol level of someone who exercises 2 hours per week. Letter F had asked, how about 12 hours per week? So we take the same formula, but now we put in x to be 12. 204.61 minus 4.65 times 12. Okay, make sure you take a look there. 148.81. Predicted cholesterol level. Now understand that that's not going to be the cholesterol level for every person who exercises 12 hours per week. Remember, there's other variables besides just hours of exercise that can influence this answer. But for our purposes here, for a simple linear regression, that's what we're going to predict. Okay. G asks, what about 20 hours per week? Now you could put 20 into the formula, but you're not actually doing it correctly. So you would say 20 is outside of x values that had a low of 0 and a high of 12. So you would say something along the lines of cannot predict. That would be your answer. Can't predict, can't do it, can't find the answer, no solution, something like that. So that's how it's done. You're given the x's and the y's, and then you come up with 3 new columns, and you get all the sums, and then you answer all the questions based on the formulas. All right, let's do another one. So here's a second question. So I'm going to show it to you, and then I'm going to have you probably do it on your own. But it says number 2, a teacher wants to know if there's a relationship between a student's exam number 1 grade and their overall course grade. So can we predict somebody's overall course grade based on how they did on exam number 1? So a sample of students is given below. So the first student got a grade of 63 on the first test, ended up with a overall course grade of 72, and et cetera, et cetera, et cetera. There happens to be 1, 2, 3, 4, 5, 6 students that we completed the grade and the course. Okay. What we need to do is we need to create an x squared column, an x times y column, and a y squared column. We're going to do that in just a second. And then I'm going to scroll up and I'm going to give you the questions. So question A says find r. B says find r squared and state its meaning using 2 sentences. C, what variables other than exam number 1 grade could we use to predict the course grade? D, what is the equation of the regression line? E, predict the course grade for a student with an 80 on exam number 1. And then F, predict the course grade for a student with a 94 on exam number 1. So I'm going to scroll. Those are the questions. There we go. And what I want you to do is pause the video. I want you to do this on your own, and then you can come back, obviously, and see if you did it right. Okay. So hopefully you're back. And I'm just going to fill in this chart here as we go. So again, this is the x value squared. So I'm going to take 63 and I'm going to square it. So 63 squared, I'm going to get 3969. Now if you have all these values, of course, you're going to fast forward the video right about now. 7225, and you don't need me to watch all of this stuff. 8464. 5476. Okay, this is x times y. So 63 times 72 is 4536. 85 times 90 is 7650. 92 times 90 is 8280. 74 times 88 is 6512. 85 times 63 is 5355, and 60 times 78 is 4680. Now we got to do y squared, so we got to take 72 and square it. 5184. 90 squared is 8100. 90 squared is 8100. 88 squared is 7744. 63 squared is 3969, and 78 squared is 6084. Now we want to add these up, so we're going to add up the x's. 63 plus 85, and 92, 74, 85, and 60. We're getting back 459. That's the summation of x values. Then we're going to add up the next one, 72 and 90, and another 90, 88, 63, and 78. We're getting back 481. That's the summation of the y columns. Okay, 39, 69, and 72, 5, and 84, 64, 54, 76, 7225, and 3600. This is 35,959. That's the summation of x squared column. 45, 36, and 60, 76, 50, 82, 80, and as we go down the list, I'm getting back 37013 is the summation of x times y, and then adding up the last column, I'm getting 39181. That's the summation of y squared. Okay, so part A says find r. Okay, we need SS sub xy, and then also SS sub xx and SS sub yy. So XS sub, this is the summation of xy minus the summation of x times the summation of y divided by n. That's on the formula sheet. We got to fill in for all of these values. Okay, so the summation of xy is 37013. Summation of x is 459. We're going to multiply that by 481, summation of y, and divide by n. If you recall, 1, 2, 3, 4, 5, 6. Okay, so in our calculator, we're going to put in 37013 minus 459 times 481 divided by 6. We're getting back 216.5. Now we want the SS sub xx value, summation of x squared minus the summation of x's quantity squared over n. I need to fill in for this and this and this. Okay, summation of x squared is 35959. Summation of x's is 459 squared divided by 6. 35959 minus 459 squared divided by 6. 845.5. And then lastly, we need SS sub yy. That formula from your formula sheet is summation of y squared minus the summation of y is the quantity squared divided by n. We need that and that and that. Okay, summation of y squared is 39181. The summation of y is 481 squared divided by n, which is 6. 39181 minus 481 squared divided by 6. 620.83. We go 2 decimals for each one of those answers. Now we can fill in for r. So r, according to the formula on our formula sheet, is SSXY divided by the square root of SS sub XX times SS sub YY. XY we found to be 216.5. Square root SSXX 845.5 times 620.83. Now if you recall, this value had better be between -1 and +1 or we made a mistake. So let's see what we get. 216.5 divided by the square root 845.5 times 620.83. 0.2988. So let's call that 0.30. So this tells me I have a positive relationship between X, which is grade, and Y, which is course grade. Exam number 1 grade is X and course grade, which is Y. And it's also kind of it's more of a weaker relationship. 0.30 is closer to 0 than it is to 1, so it's more a little bit on the weaker side. We would like to find what R squared is. So we're going to take 0.30 and we're going to square it. Put right here. 0.30 squared is 0.09. That again is the probability. We're going to move that over 2. We're going to get back 9. So we're going to say 9% of the Y variable, which is the course grade, is directly related to the X variable, which is exam number 1 grade. The remaining 91%, so that'll total 100, is due to other variables. Again, we're doing a simple linear regression where we're comparing just one X, which is the exam number 1 grade, to the one Y, which is the course grade. And we're saying that 9% of the reason why your course grade can be backtracked because of your exam number 1 grade. Okay, so that's A and B. C asks, what variables other than exam number 1 grade could be used to predict the course grade? Well, you could say hours of study. You could say previous math experience. Now, the number one thing in any class, doesn't have to be a math class, in college or high school, the number one thing that affects a student's grade is the teacher's ability. That's been proven time and time again. Teacher's ability to teach. Better teacher ability, better success rate for the students, etc. So you fill in for a bunch of other ones. Okay, so now D. So we have the relationship. It's a positive relationship and it's weak, which means, can you really rely on your exam number 1 grade to predict the course grade? Well, not really. It's pretty weak relationship. I would look at other things than just your exam number 1 grade, what your course grade is going to be. Go with some of these are going to have more experience. Also, like your attendance level, and do you have homework? Do you do your homework on a regular basis? Stuff like that. Well, now, D, what is the equation of the regression line? All right, so that is y hat equals a plus bx. Your goal is to find a and b. Okay, we got to find b first. B is ss sub xy divided by ss sub xx. 216.5 divided by 845.5. That's the xy value that we found earlier, and that's the xx value that we found earlier. So we're going to put that into our calculator. Okay, here we go. 216.5 divided by 845.5. And we're getting back 0.256. Let's call that 0.26. So we're halfway home with our B. Our A, go over here. Our A is 1 over n, summation of y minus b times summation of x. So we have to fill in for the n, the y, the b, and the x, summation of x. Got it. So 1 over n in this question is 6. Summation of y, scroll up, summation of y we found earlier to be 481. Minus b we just found to be 0.26. Times the summation of x. If I scroll up, summation of x we found to be 459. So in our calculator we're going to put in 1 divided by 6, 481 minus 0.26 times 459. $60.276. Let's call that 60.28. So the actual equation to the regression line is y hat to be a, we found to be 60.28, minus b, which is 0.26, times x. That's the equation of the regression line. X in this case is the exam number 1 grade, and y is going to be your final course grade. So for part E, they asked me predict the course grade for a student with an 80. Well, I need to go up here and I need to find my low X value is 60. My high X value is 92, based on the X's that were offered to me in the question. So I can predict anything from 60 to 92. So anything less than 60, I can't, and anything greater than 92, I can't. So they're asking for an 80. Well, that's okay. 80 is within the range of X's that I have. Okay, so I'm going to take the value 80, which is my X value, and I'm going to put it into the equation. So y hat is 60.28 minus 0.26 times 80. Oh, I'm sorry. I made a boo-boo. It's a plus bx, silly me. And the a was 60.28, and the b was positive 0.26. This should be a plus b. Forgive me. I apologize. That should be a plus. I caught myself, thank goodness. So when I actually go over here to predict, this had better be a plus. Okay, so it's a plus bx. The reason why it was negative in the first question is because b was negative. In this case, b is positive, so it stays positive. So now let's find that value. 60.28 plus 0.26 times 80. 81.08. So here's the thing. If a student comes and says to the professor, I got an 80 on the first test, how do you think I'm going to do in the class? You could say, well, I predict based on previous experience that according to my linear equation, you should get an 81.08. But remember, attached to that is a weak relationship for this equation. So that means this is a very weak prediction. Not a very solid prediction, it's very weak. So you can tell somebody that, but it doesn't really mean much. Predict the course grade for a student with a 94. Well, that 94 is not within my low of 60 and high of 92. It's outside of that, so you're going to say I cannot predict. 94, you don't have to write this, but 94 is more than the high X value of 92. That's the reason why you can't do it. But you just simply can't make a prediction on that. So that's how you do simple linear regression. And I hope do the homework. Any questions, send me an email and I can help you out again. But hopefully this helped you in understanding how to do the whole process. Okay.